Welcome friends, welcome to Sanjay Agarwal Maths classes. I am Sanjay Agarwal. I have been teaching Maths to class 12 students for last more than 30 years. So I have been mainly teaching them across the blackboard as physical classes. Lately I have decided to digitize my classes for the benefit of the students across the globe. So I am very hopeful and very sure at the same time that the video lectures now which you will be going through over a period of time will be very useful to you. So I have been going to use my experience of more than 3 decades and bring to you maths in a very simplified manner. The today's class is on vectors. We will start from the beginning. Every lecture will be of half an hour, and most likely the number of classes of vectors or the number of episodes of vectors will be more than 20. So that will be almost 10 hours of lecture on vectors. So without wasting any time, let us start the chapter on vectors of class 12 maths. So what are vectors? There are two kinds of physical quantities: scalar quantities and vector quantities. Now, what are physical quantities? Physical quantities are those which can be measured, like length, area, volume, mass, weight, speed, displacement, momentum, force, temperature, pressure. All these are physical quantities. You can measure them. Are there any quantities which cannot be measured? Yes, you can say happiness, sadness, intelligence. They cannot be quantified, they can't be measured. So all these physical quantities are the one which we come across in physics. So these physical quantities are classified as scalars and vectors. So what are scalar quantities? Scalar quantities are those which can be represented completely by a number. That number can be a negative, positive or 0. They don't have any direction. And vector quantities are those to explain them or to describe them completely. We need a magnitude, a number associated with the vector as well as a direction. Let us take examples of scalar quantities: length, pressure, mass, distance, speed, temperature. These are scalar quantities. So when I talk about mass, say the mass of certain object is 10 kg, there is no need to say any direction. The distance is 5 km. The speed is 2 km per hour. So these are your scalar quantities. Vector quantities is like, say, force. An object is being pulled with a force of 5 Newton in a particular direction. So force is a vector quantity. Velocity, in velocity we talk about speed as well as the direction. So that is a vector quantity. Momentum is a vector quantity. So we have physical quantities classified into scalar and vector quantities. So we will now do vector quantities, and let me now start the class. Those students who are physics students have done vectors in class 11 also. So for them it will be easier, but non-physics students will face a little challenge in the beginning, but as we go down the class, they will start enjoying this class and they will be also comfortable with the vectors. So let us start with vectors. This will be episode 1 of your vectors of half an hour. So this is a chapter of class 12 and it's an independent chapter. If you have not done chapters prior to this chapter like matrices and determinants, trigonometry, inverse trigonometry, differentiation, application of differentiation, integration, application of integration, differential equations, it does not matter because it is an independent chapter. Everybody can do it without any previous chapter. So it won't be difficult for you to start and understand vectors even if you have not done previous chapters. So vectors you can note it down also simultaneously. Physical quantities which has a number associated with it, we'll call it as a magnitude, always a positive number, and a direction. So physical quantities, those physical quantities which has magnitude and a direction are called vectors. So vectors are physical quantities which has magnitude, which is always a positive number, and a direction. Now, how do I represent vectors? There are two ways of representing vectors, geometrically and algebraically. First, we will discuss about geometrical representation of a vector. So, how do I represent a vector? Vectors are represented by directed line segments. So, geometrically we represent vectors by directed line segments. The length of the line, or I will say the length of the line segment, will be the indicator of the magnitude of the vector, and the actual direction of the line will be the indicator of the direction of the vector. Let me draw a line segment. So, let me name it as A, B and put a direction from A to B. Alright. So, this will be called the tail of the vector, this will be called the head of the vector, and we can represent this vector with two alphabets, capital letters A, B. So, this vector starts from A, terminates at B, this is a straight line, and the length of this line will be the magnitude of the vector. Suppose the length of this line is 5 units. So, the magnitude of this vector will be 5 units, and the direction which you physically see on the blackboard will be the direction of the vector AB. So, how do I represent the magnitude of the vector AB? So, this vector AB will have two informations. It will have a magnitude which will be represented like this. So, this is a modular symbol, but we will call it as magnitude of vector AB. Why this symbol was selected? Because the magnitude of the vector AB will never be a negative number, and the modulus also ensures that the number inside the modulus symbol is a positive number. And the other information will be the direction, because every vector has a number, a magnitude, a positive number and a direction. So, when we are representing vectors by two letters, we will use capital letters. First letter will be the tail from where your vector starts, and the second letter will be where it terminates. That will be called as the head, or the initial point and the final point. And if you want to represent a vector by a single letter, normally we will use small case letter like this, A with an arrow on the top. So, vector AB can also be written as vector A. So, if I am using a small letter, single letter, I will use a small case letter to represent a vector. If I am using two letters, I will use a capital letters to represent the vector. So, how do I represent vectors? I represent vectors geometrically by directed line segments. Now, free vectors and localized vectors. What do you mean by free vectors and localized vectors? Free vectors versus this noise of the chalk hitting the blackboard is something you have to bear, because I cannot use a marker pen on a white blackboard. That somehow the fumes coming from the pen is not good for my throat. So, this is something you will get used to it. So, free vectors versus localized vectors. Now, what do you mean by free vectors? Free vectors means vectors can be moved anywhere in the space, but of course, you can't change their magnitude and their direction. And localized vectors cannot be moved in the space. They are stationed in a particular place in the space. Like I have a vector AB, okay, say magnitude 3, pointing in the direction you can see on the blackboard, whatever you can call it, pointing towards right, pointing towards x axis in the increasing direction of x. Now I move this vector and make it here. I don't change the length and I don't change the direction, both have the same direction. I draw it here. So this is what exactly I mean by free vectors. You can carry your vector anywhere if you don't change its magnitude as well as direction. Wherever you take it, they will be all same. Like this pen, I hope you can see it. So this is a vector pointing in this direction. Now I take it up, or I take it here, or I take it here, or I take it here. All vectors are equal, they are same. And how do I represent localized vector? Suppose I am talking about a two-dimensional vector. This is positive x-axis, this is positive y-axis, negative x-axis, negative y-axis. I have a point here 2, 2 and I make a vector here a, b. So this will be say 5, 2 and it is parallel to x-axis. Alright, so the magnitude of this vector is also 3 and the direction is same as this, but now I can't move it because we have fixed that the tail will start from 2, 2. So this becomes a localized vector, but most of the numericals will be handling free vectors. So now you know what is the difference between free vectors and localized vectors. Free vectors can be moved anywhere in the space, but obviously it's understood you can't change their magnitude as well as direction. Alright. Now when are two vectors said to be equal? Of course, two vectors will be equal when they have the same magnitude as well as the same direction. Suppose I change these alphabets from A, B to C, D. So then I can say vector AB is equal to vector CD because both have same magnitude as well as both have same direction. So now let me quickly recap what I have spoken till now. Vectors are physical quantities which have both magnitude and direction. To describe them completely, magnitude of the vector is always a positive number. Magnitude can be vectors can be represented geometrically as well as algebraically. In the beginning, in today's lecture and maybe in the next lecture also, we will be handling vectors geometrically, but the numericals when we do, they will be done algebraically and they will be much faster. So this understanding of geometrical representation of vectors is good for you to get a better insight into the vectors. Otherwise, one can start directly from algebraic only, but then you really don't understand what vectors are. So we are representing vectors by directed line segments. So we understood what are free vectors and localized vectors and what do we mean by equal vectors. So two vectors are said to be equal when they have same magnitude as well as same direction. Now what are parallel vectors? As the name suggests, parallel vectors may also be called as like vectors. There won't be any numericals on this portion. Numericals will come from algebraic representation of vectors, and that's much easier to understand and to figure out and to do numericals. Two vectors are said to be parallel, obviously, when they are in the same direction and parallel to each other. They may have different magnitude, but their direction should be same. So parallel vectors may also be called as like vectors. So two vectors are said to be like when they are parallel or when they are in the same direction. When they are in the same direction, obviously they are parallel also. And what are anti-parallel or unlike vectors? So they are parallel but in the opposite direction. So they are called anti-parallel or unlike vectors. So this is one vector and this is another vector. They may be having different magnitudes, they may have same magnitudes. Magnitudes have no inference here. So these two vectors are parallel, but we will call them as anti-parallel because their direction is opposite. But when we go further in the chapter and we say parallel vectors, we will consider parallel vectors. This also we will call it as parallel vectors, this also we will call it as parallel vectors, whether they are pointing in the same direction or they are pointing in the opposite direction. But if we have to specifically differentiate between parallel vectors and anti-parallel vectors. If we have to specifically differentiate between parallel vectors and anti-parallel vectors, then this is it. Otherwise, parallel vectors will be, the term parallel vectors will be used in the broader sense, which will mean in the same direction or in the opposite direction, but parallel to each other. Alright, next, null vectors. So, these are the definitions I am taking you through, like what is the vector, second, what is the magnitude of the vector, third, what are free vectors, fourth, what are localized vectors, fifth, what do you understand by equality of vectors, sixth, what are parallel and anti-parallel vectors. Now, the next vector is null vector. So, as the name suggests, the symbol for null vector will be 0 with the arrow. So, as the name suggests, null vector is a vector whose magnitude is 0. So, its starting and finishing point is same. So, if I start from A and don't go anywhere, I stay at A, so it can be called like this. So, AA will be a null vector because you are not even moving from A, you are at A and you are terminating at A. So, this will be a null vector, or I will use a symbol like this. So, what is the magnitude of null vector? So, this is the symbol of magnitude. The magnitude of null vector will be 0. Now, the important question which can be asked for 1 mark for a null vector is, what is, this is a nice question. See, every child will say, if they ask what is the magnitude of null vector, I am sure 100 out of 100 students will say the magnitude of the null vector is 0. But this lot of students will make a mistake. The question is, what is direction of a null vector? So, some of us may say null vectors do not have any direction. So, that answer will be wrong. Why? You know why? Because I said null vectors. The moment I say vector, it has to have a direction. Vectors have a number, that number will be 0 and the direction. So, you can't say null vectors do not have any direction. What we say is their direction is unspecified. They do have a direction, but it is an unspecified direction, because you are not even moving from where you are standing. You are at A and you are still at A. So, I can't say that you don't have direction, because that I am not allowed to say, because vectors have direction. So, we will say their direction is unspecified. Now, I move to the next kind of vector, and this vector I will be using very often, called a unit vector. As the name suggests, a unit vector is a vector whose magnitude is 1. Obviously, the name we have taken is like that. A unit vector is a vector whose magnitude is 1. What will be the direction of unit vector? That will be various directions depending upon what's given in the question. So, if A is a unit vector, so at least I can say that its magnitude is 1. I can't say what is its direction, because that will be different in different questions. You may have many unit vectors in one particular numerical itself. So, unit vectors are those whose magnitude is 1. Now, since unit vectors are used so often, we like to give it a different symbol. So, what we do is, this is also a symbol, but here I have to write it is a unit vector, otherwise I won't know. But if I put this symbol on this, like a cap, then without even asking, without even telling, I will say it is a unit vector, because this symbol is reserved for unit vectors. So, for unit vector we will use a cap instead of a arrow. But if I use a arrow, that does not mean it is wrong. Only thing is, you won't know it is a unit vector till somebody tells you it is a unit vector. But if you put a cap, nobody has to tell you, you know it is a unit vector. So, what is the magnitude of this vector? You won't be able to tell me unless somebody tells you what is the magnitude of this vector. But if I make a cap on this and ask you what is the magnitude of this vector, you can with full confidence say, sir, the magnitude of this vector is 1. So, unit vectors are the vectors whose magnitude is 1. Now, let me draw 3 axes, x axis, y axis and z axis. Now, let me consider 3 specific unit vectors. one along x axis, or I can also say parallel to x axis, unit magnitude 1, one along y axis magnitude 1, and one along z axis magnitude 1. When I say along x axis, it could be like this also, because it's one and the same thing. I told you vectors are free to move in the space. You can bring this vector and coincide with x axis, so you don't have to be physically coinciding with x axis. And you know what is the direction? It's pointing in the direction in which the x coordinate is increasing. This is also pointing in the direction in which the x coordinate is increasing. So a unit vector along x axis pointing in that direction in which x coordinate is increasing. Say x coordinate will be 0, 1, 2, 3, 4 like this. So this unit vector along x axis pointing in the direction in which the x coordinate is increasing will be used in each and every numerical. This is the unit vector along y axis pointing in the direction in which the y coordinate is increasing, and so is this along z axis. Since they will be used maybe more than 400 times throughout the chapter of vectors, but obvious we shall give them special symbols. So we give a special symbol I cap, j cap and small k cap. So what is I cap now? I cap is a unit vector along x axis. When I say along x axis, we will presume it is pointing in the direction in which the x coordinate is increasing. And j cap will be a unit vector pointing in the direction in which y coordinate is increasing. So it will be along y axis or parallel to y axis, that means one and the same thing. So I cap, I am not writing the definition, I am speaking, you can write it down in your exercise notebook. I cap is a unit vector along or parallel to x axis. J cap is a unit vector along or parallel to y axis, and k cap is a unit vector parallel or along z axis. Now if I draw, I will rub this off. If I draw a vector like this and put an arrow here. Now this vector is and magnitude 1. This vector is also along x axis, but it is pointing in the direction in which x coordinate is decreasing. Physically I meet it on positive x axis, that does not make a difference. See, this is a unit vector, I put it here, I draw it here, I draw it on negative x axis, I draw it here, I bring it outside the blackboard. As long as they all stay parallel to each other and the magnitude remains 1, they will be all equal vectors. So don't get confused that the vector has to be physically on x axis. So this is a vector parallel or along x axis, but pointing in the direction in which the x coordinate is decreasing. So the symbol we are going to use this will be minus I cap. So we will have 6 unit vectors, I cap, j cap, k cap, minus I cap, minus j cap and minus k cap. Be careful, minus I cap does not mean the magnitude is minus 1. Magnitude of every vector is a positive number. It is never a negative number. So its magnitude is 1, its magnitude is 1, its magnitude is 1, magnitude of all these 3 are also 1. Only thing is the minus is indicator of the direction. It means the direction of this vector will be opposite to of that. Minus j direction will be opposite to that of the direction which vector j is having, and minus k vector direction will be opposite to that of k. So they will be along, this will be along x axis pointing in this direction, this will be along x axis pointing in this direction, and similarly we will go with j and k. So as we go further in the chapter, these unit vectors will be used in each and every numerical. So now you are familiar with 3 very important unit vectors along x axis, along y axis and along z axis, and we have given them special symbols I cap, j cap and k cap. And if they are in the opposite direction but along x and y and z axis, minus I cap, minus j cap and minus k cap. Alright. So now what we have done, we have understood what is the definition of vectors. Vectors are physical quantities which have magnitude as well as direction. What is the magnitude of a vector? It is a positive number which gives us the length of the line segment which is representing the vector, and direction will be given in the question if you are geometrically representing the vectors. So then what are free vectors? What are localized vectors? what are parallel vectors, what are anti-parallel vectors, what is a null vector, what is a unit vector, what do you understand by equality of vectors. Two vectors are said to be equal obviously when their both parameters are equal, their magnitudes are equal and their direction is same. Now the next topic, negative of a vector, as the name suggests, and we have already covered unknowingly negative of a vector. So as the name suggests, or as I described here, negative of a vector is also a vector having same magnitude but opposite direction. Negative of a vector is a vector having same magnitude but opposite direction. Suppose you are given a vector AB. Now you want to write minus AB. This I will speak as negative of vector AB. Obviously, this is vector AB, this is minus with AB. So this is negative of vector AB and this will be same as vector BA. So negative of vector AB will be same as vector BA, because AB is a vector. Let me draw a diagram for you. See here, this is A, this is B and this is the direction. Unit whatever you can take, magnitude say 2. Now what will be BA vector? This is B, this is A, so this is BA. Now this also will have the same because the line segments are same, only difference is the direction. This is pointing in this direction, this is pointing in this direction. So vector AB and vector BA. So they are of same magnitude but are opposite direction. So I can say negative of AB is vector BA, or negative of vector BA is equal to vector AB. Alright. So while doing numericals, if there is a need to change the head and tail, you can go ahead and do it. Suppose I am doing a numerical, okay, and there arises a need to write AB as BA. So in the next line you can write it as, let me write it little above, this portion of the blackboard may go out of the screen. So suppose I am writing vector AB. Now in the next line, for some reason I want to write B in front and A later. So you go ahead and do it, B, then you write A and then but put a minus sign. If you don't put a minus sign, they won't be equal because AB is not equal to BA. Because AB direction is from A to B, BA direction is from B to A, they are anti-parallel vectors. But if you put a negative sign, its direction will also become from A to B. So I can make a formula for you. One alphabet I can represent by a box, other alphabet I can represent by a triangle. So for some reason you want to write triangle in front and the box at the back, you can do it, but then don't forget to put a minus sign. So that finishes the negative of a vector. So negative of a vector is a vector having same magnitude as the given vector but direction will be opposite to that. So in the same scenario this comes here. I cap is a unit vector along x axis pointing in the direction in which the x coordinate is increasing. Minus I cap is also a unit vector along x axis but pointing in the direction in which the x coordinate is decreasing. So I'll end the class here. This episode is almost becoming half an hour long. So there will be a break for you. You can recap what I have taught you so that when you join in the next class, you will be able to pick up from where I'll start. So bye for now. We'll see you soon in the next episode where we'll continue from here. The last topic was negative of a vector. From there, we'll continue in the next episode on vectors. Bye for now. Have a nice day.